A 79 kilogram student rides a lift to the top floor of an office block. During the journey, the lift accelerates upwards at 1.26 meters per second squared before traveling at a constant velocity of 3.78 meters per second and then finally decelerating at 1.89 meters per second squared. Part A, calculate the apparent weight of the student in the first part of the journey while accelerating upwards at 1.26 meters per second squared. All right, so let's have a lift. There's a student in the lift. We know that we have an acceleration upwards of 1.26 meters per second squared. All right, so we know that that acceleration upwards is caused by our net force. Any acceleration is caused by the net force. So F net equals ma. So our student is 79 kilograms. Multiplied by 1.26, and so the net force acting upwards is whatever that is. And I get 95.76.
I got 99.54.
Really?
Yeah.
Oh, yep, sorry. I mixed up my 6s and my 9s. Let's try that again. 79 times 1.26. Yep, 99.54. Okay, so our net force is 99.54 newtons upwards. And then we use our other equation. Our net force is equal to Fg plus Fn. Okay, if we want the apparent weight, we need our Fn value. So in fact, we can rearrange this. Fn is equal to Fnet minus Fg. All right, so we know our net force is 99.54 minus our Fg force. Now I'm calling Fnet is moving upwards, so I'm calling that the positive direction. Fg, therefore, is going to be in the negative direction. Okay? So if we're subtracting Fg, we need to subtract a negative. All right, because I've got this equation, we worked out that Fnet minus Fg is our Fn, but Fg is downwards in the opposite direction, so we are minusing a negative. And so, what is Fg? 79 multiplied by 9.8. So in total I get 873.74.
No, just 874.
Sorry?
No, it's 873.
Oh yeah, but you're saying can you round it to 874? Yeah, absolutely. Okay, and so we see that this force, our apparent weight, is larger than mg. So this means that if you're in a lift accelerating upwards, you will feel heavier. Okay, the apparent weight is larger than your normal weight, so you would feel heavy if you're moving upwards. And we've all done that. Get in a lift, as it starts to move upwards, and it makes sense, you're sort of pushed into the floor a bit. Okay, because of this apparent weight. Calculate the apparent weight of the student in the second part of the journey while travelling at a constant speed of 3.78 meters per second. Okay, this is a little bit easier. What is our net force? 0. There is no acceleration. We are travelling at a constant speed, so there is no acceleration. So Fnet equals 0. And so from our other example, or our other equation, Fnet equals Fg plus Fn. If Fnet is 0, then Fg equals negative Fn. So they are the same magnitude, but opposite in direction. So Fn is just equal to Fg. So we can work out Fg then. 79 multiplied by, what's it, 9.8? Did we get an answer for that before? 774, yep. Okay, and so in this case, our our weight force is equal to our normal force, and so you wouldn't feel heavier or lighter than usual, you would feel your usual weight. Okay, the last one, calculate the apparent weight of the student in the last part of the journey while travelling upwards and decelerating at 1.89 metres per second squared. So in this case, we are still travelling upwards. There's our student again. We are still travelling upwards, but the acceleration is downwards. It's still going upwards, but it's slowing down. So the acceleration is actually downwards. Our acceleration is 1.89. Oops, it's at 2. So again, we do this similar to the way we did part A. Our F net equals MA, which is equal to 79 multiplied by 1.89. $149.3 as our F net. Okay, so we've got our F net, and we know that F net is equal to Fg plus normal force. We want our normal force.
So would that be negative?
Sorry?
Would F net be negative?
F net, well, it depends. We're calling up or down.
Down.
Yeah, it just depends. As long as you do it, as long as you're consistent, it doesn't matter. We'll still call up positive, and we can change that here. It's okay. We can do it now. So F net minus Fg. Okay. So if we are calling up positive still, let's get our notation right. So up is positive. So does that mean our normal force is going to be positive or negative? Positive. Yep, up is positive. The floor is pushing you upwards, so our normal force is positive. What about our net force? Negative, because our net force is acting downwards. What about our gravitational force? Oh, I'm hearing a few there. Our gravitational force, in which direction is it acting? Down. So it's negative. So, negative Fg. Okay, so a net force, 149.3, plus our gravitational force, because it's a negative, and so we get 624.9 newtons. And so from this we can see that our normal weight is 774. Our weight in this case is 624.9. Our apparent weight is less than our normal weight, so you'll feel lighter than you normally would. Okay? The only real trick to a question like this is this step here, getting the positives and negatives around the right way. Just be consistent. Okay? If you're calling upwards positive, that's fine. You just need to work out in which direction those forces are acting and make sure you don't mess up your positives and negatives. Okay? And if you're stuck, if you really want a way to check that you've done this correctly, think about your own experience in a lift. Okay? As a lift moves down, as it accelerates downwards, you feel lighter. Right? Your stomach sort of lifts. All right? If it is accelerating upwards, you'd feel heavier. You get pushed in. So just double check that your experience lines up with your answer here.